Welcome to the Exam Study Expert Podcast, helping you ace your exams at school and university through the psychology of high performance and the science of studying smarter, not harder. It's my pleasure to introduce your host, the Cambridge-trained memory psychologist and exam success coach, William Wadsworth.
Hello and welcome to this 7th part of our 8-part audio course on how to study effectively. Yes, we're on the home straight now with only one more instalment to go after this one. If you've been enjoying the How to Study Effectively series so far, please do stay tuned to the end of this episode when I'll be making a very special announcement about how you can order the book that accompanies the How to Study Effectively series. The book is essentially a richly illustrated transcript for everything we've covered in the audio course. I'm hugely excited to share this news with you. It's going to be a great book to accompany the series, so please do listen out for more news about that at the end of today's show. But for our main feature today, let me first explain a little of the context for today's episode on interleaving. When I was designing the course, this 8-part series on how to study effectively, I thought of it as a bit like a sandwich. You've got parts 1 and 8, which form the bread around your sandwich. Both part 1, which was episode 66, and part 8, which is coming up in a couple of weeks' time, I'd consider must listen episodes. You've got to have your bread around the sandwich, the first part and the 8th final part, because part 1, that first part, gives us that kind of foundational, those sort of foundational principles upon which so many of the techniques that we've covered and the remaining parts of this series are based. If you don't have those foundational sort of understanding of the principles, then the techniques we've talked about in the rest of the series don't make so much sense. Then part 8, I would also consider to be essential listening, because that's kind of the thing that brings everything together and explains how all that we've talked about in the series can kind of work together as a complete study system. So what about the middle episodes? So like the filling in any decent sandwich bar, there includes an element of personal choice here. So while I'd strongly advise, as I say, listening to the 1st and the 8th part, that first part is already out, episode 66, the 8th part is coming up in a couple of weeks' time. Those middle episodes, including today's, it's a bit more up to you about what you listen to and which strategies are more important to you, depending on things like the kind of course you're studying, as well as your own personal preferences. So it's not necessary to use all of the strategies in the 2nd through 7th parts of the series, but if you want to study effectively, you almost certainly want to be using at least 1 or 2 of the episodes worth of material from those middle episodes 2 through 7. So today, for the 7th episode, we're going to be talking about interleaving. Interleaving is probably not a term you've heard before, unless you've caught one of our previous episodes which dipped into it, in particular the episode we did with Dr. Veronica Yan a year or so back. But interleaving is a powerful and relatively little known study strategy, which is particularly handy when you're studying math, or maths as I call it, and the maths style problems that come up not just in mathematics itself, but really wherever you find maths style problems and calculations, for example, throughout the sciences, in business, economics, accounting, engineering, medicine, and much, much more. When used properly, the technique of interleaving will help you master the art of solving particular types of problem in less study time, and really enable you kind of retain that mastery for longer and be more confident and accurate in solving those types of problems correctly in an exam or test type situation. I often talk to students who are studying maths or, maths style problems, as I say, that come up in lots of different kinds of other subjects. And I hear complaints like, I'm fine when I'm sort of practicing the problems at home, but then I get into a test and things fall apart and I can't do it as well. Well, interleaving is a really important strategy for helping you kind of overcome that and making sure that it, as always, in a very efficient amount of study time, not necessarily working longer, but working smarter, as always, interleaving allows us to learn how to solve those problems to a better standard so that we're much more able to deliver in the tests and exams when it counts most. So it sounds like a great promise. Let's talk about what exactly interleaving is and how it all works. So I always say that the easiest way to understand what interleaving is to first understand what interleaving is not. So the opposite of interleaving is called blocking. Blocking, the opposite of interleaving, is really a pretty familiar way of studying for most people. It's kind of the default way of organising our practice for most of us. It's how textbooks are laid out. It's how teachers generally set problem sheets for homework and assignments. Let's demonstrate this with an example. Let's say we were learning some very basic arithmetic and we'd just met addition and subtraction. So all the way back to the early days of your school career, and I'm sure an example that will make sense for everybody. So you'd learned how to do addition one week at school, you'd learned how to do subtraction the next week at school, and the teacher sets you some homework sheets on both sets of arithmetic problems over the weekend for practice. You start with the addition problem sheet. Let's say that takes you an hour. You're a very hardworking 6 or 7 year old or whatever. And then you take a break. So the addition takes you an hour. After that, you take a break, come back and do the subtraction problem sheet. That takes you a second hour, and then you're done. Again, I'm just using addition and subtraction as examples here. It really could be any type of problem. Differentiation and integration is a great example if you're familiar with basic calculus. So anyway, the core principle here is blocking is about doing your work in big chunks. A long stretch of one type of problem, say addition first, and then a long stretch of a different type of problem, say subtraction second, on a different day, later in that same day, maybe a week or two later. Chunking up your work, focusing on one type of problem in a given sitting. Now, look, this is a perfectly sensible and intuitive way to organise your work, but there is a problem. Often, the real challenge when we get into exam situations is kind of remembering the methodology you need to tackle each and every different type of problem. Exams don't present you with large strings of all the same kind of problem most of the time. They're often jumbling up different sorts of problem from right across your syllabus, right across your studies that you've covered recently. And often the challenge is looking at each fresh type of problem that you're facing in an exam and trying to remember, how does this type of problem work? What formulas do I need? What steps do I need to follow? And perhaps even just recognising what problem you're looking at in the first place, so you can decide, this is that type of problem, or this is another type of problem. I need a different methodology. The problem with blocking is it really doesn't help with this challenge at all. It doesn't help us prepare for the challenges we're faced with in an exam where you see lots of different kinds of problem. Because the thing about blocking is by the time you've done your first few problems of a given type, that methodology is now rattling around in your short-term memory. So you do the first edition, you do the second edition, you do the third edition. Now you're kind of getting quite comfortable with addition and you're sort of getting into the groove, you're getting into the flow. You don't get to practice that crucial moment of, this is an addition problem. I haven't seen one of these so far in this exam. What methodologies do I need? How do I need to solve this problem again? What tools do I need? How does it work? You only get to practice that feeling of, how does addition work? The first problem or two of the sheet. By the time you're on problem 19 or 20, you don't need to kind of remember that anymore. You're just in 20 other problems that are identical to it or very similar to it. You don't need to have that practice of, how does this problem type work again? Because you've just done so many problems of all the same type. You kind of get into the flow as you do the first few. So you don't get to practice that crucial moment of seeing a problem for the first type of problem for the first time and then figuring out, what methodology do I need? What are the elements I need to solve this problem? So is there a solution? There is. That's what this episode is all about, and it's called interleaving. Interleaving, as the name sort of hints, involves shuffling up different types of problem, mixing them up. So rather than doing your hour of addition, a second hour of subtraction, you just do maybe a couple of problems of addition, then switch over and do a couple of problems of subtraction. A few minutes on each, a few problems of each, constantly flipping back and forth between the two techniques. Some addition, some subtraction, some addition, some subtraction. Or to use a more sort of grown-up example, differentiation and integration works well. Really basic calculus that I know many of you have probably met as well. So rather than tackling your differentiation problem sheet on Tuesday night and your integration sheet on Wednesday night, you tackle both sheets at the same time, maybe break it up and do half on Tuesday, half on Wednesday. But within each practice session, you're doing a couple of problems of differentiation, then a couple of integration, or maybe just one of each problem of each type, constantly switching back and forth between those two types of problem. That's interleaving. mixing up two related kinds of problem practice and constantly flipping between practicing the two kinds of problem. When we start to do interleaving, there are three major benefits. Number one, it gives you practice over and over again at that crucial skill of remembering, how does this problem type work again? So interleaving very deliberately stops you getting into that groove where every new problem after the first one or two feels easier and easier because you can remember the methodology from the previous questions. By forcing your brain to switch and tackle a different kind of problem, when you then switch back and tackle another of that original type of problem, you get to have another one of those moments of reaching back into your long-term memory and retrieving the information you need to unlock the methodology that you need to solve the problem. When you think about it, exams, particularly big ones at the end of a year or term or semester, are usually testing lots of different kinds of problems. So for every single problem you face in an exam, you're coming into it cold, not having done a whole run of similar problems to warm up on. Interleaving, you can think about it. Interleaving lets you practice those cold starts over and over again on a given type of problem. Because each time you switch back to that type of problem, having done a different problem type in between, that's fantastic practice, giving you kind of one of those cold starts of remembering, how do I do this problem type again? And the more of those cold starts you do, the easier it will be when you have to do those cold starts facing a new problem for the first time when you're in the middle of an exam. Interleaving, in other words, makes it much easier to retrieve and access your memory for how to use the methodology you need to solve the problem when you're sitting there in the exam. Interleaving does more than that, though. So the second nice thing that interleaving does relates to spotting which kind of question you're faced with. Sometimes the battle is half won once you've just recognised which kind of problem you've got, and therefore what kind of methodology you're going to need to try to recall to solve it. Sometimes it's just recognising, is it this kind of problem? Is it that kind of problem that I'm being asked? And again, by flipping back and forth between two different types of problem, you are training yourself to start recognising differences in what the questions look like, thereby making it easier to start recognising the question you're faced with on each fresh page of your exam. The third and final benefit in interleaving is all about reducing confusion, both in recognising the question you're being faced with, as I just mentioned, but perhaps especially also in confusion between different methodologies that can feel a bit similar and might easily be confused. One of the examples I've sort of been touching on so far in this podcast illustrates this quite well. So I've been referring to sort of basic calculus, integration and differentiation as an example. If you happen to be familiar with how to do basic integration, basic differentiation, you may remember that the operations you need to follow for those two types of maths problems are actually pretty similar. They're sort of kind of like the opposites of each other. To kind of differentiate, you sort of do the opposite to what you do if you're integrating. Almost. Ask any maths teacher and they will tell you that one of the most common types of errors on these sorts of basic calculus questions is trying to solve integration by kind of using differentiation methodology, at least partially. In other words, getting some or all of your methodology backwards and kind of doing the inverse of what you're supposed to do. You're trying to sort of do a little bit of integration to solve a differentiation because you got your methodologies mixed up. Once again, interleaving has a lovely solution to this challenge, because by juxtaposing your practice of those two easily confused methodologies, you quickly learn to discern between them and build up your confidence and skill in using the right methodology for the right type of problem. So for that reason, if nothing else, I generally recommend applying interleaving to two quite similar problem types that hold the potential for confusion. So interleave integration and differentiation, not interleave integration in something totally different like trigonometry. In science, physics, for example, interleave your practice of elastic potential energy and gravitational potential energy calculations in physics. Don't interleave elastic potential energy calculations and, properties of electric circuits. Or for something outside maths and sciences, let's say you're studying business and accounting, you might interleave practice on the current ratio and gearing ratio calculations, not current ratio and something totally unrelated like net present value, NPV. Now, there is no set rule about when to switch, how many of each problem type to do. I would say that if the problems themselves are quite long, maybe a few minutes each to calculate, I'd probably just do one problem of each of the two types at a time, then constantly flip between the two. One problem of type A one problem of type B, one of type A, one of type B, constantly flip back and forth between the two types of problem you're practicing. If the problem types are a little bit shorter, maybe I might do a few more, maybe up to about 4 or 5 minutes of one type of problem before switching to the second type of problem. So this all sounds great. How do we know interleaving works? Where's my evidence for all of this? It's actually one of the best studied learning strategies. So it's quite surprising that not more people know about it in education. I don't often hear teachers talking to students about it, less still students themselves using it. Perhaps partly because it's more narrowly applicable. It's not like spaced retrieval practice where it kind of works for all knowledge. It's a bit more limited to kind of certain types of problem. I've been using math style problems as examples so far, but I'll mention a couple of other applications of interleaving by the end of this episode. But what it does have in common with some of the other principles we've covered in this course, like retrieval practice and spaced learning, is that interleaving has a very impressive impact when used in the right circumstances. So in one of the most famous studies on interleaving by researchers Rohrer and Taylor in 2007, students were randomly allocated to one of two groups. Both groups were taught how to calculate the volumes of 4 different solids: a wedge, a spheroid, a spherical cone, a half cone, with exactly the same practice problems to test them on how well they learned, and exactly the same amount of time to actually do their learning and practice in the first place. The only difference between the two groups was that one group did block practice, the other group did the other group did interleaved practice. Both groups came back for a test a week later. The results were astonishing. The blocked group, so the ones that had just been doing a whole load of practice on calculating the volume of wedges, then a whole string of practice on calculating the volume of a spheroid, etc. So the group that were doing the blocked practice, practicing one type of problem at a time, scored an average of 20% on the test. The interleaved group, who'd been practicing all these different kinds of problems all jumbled up together, so they might do one wedge calculation, one spheroid calculation, one half-cone calculation, continually switching between all these different kinds of problem practice. The interleaved group, who had this sort of interleaved practice, scored 3 times higher. So rather than 20%, they scored 63%. It's 20% versus 63%. One of the most spectacular effect sizes I've come across in any of the learning principles that I teach. It's an incredibly powerful effect. So, given how impressive the results are, perhaps we should wrap up by having a quick think about how far we can stretch the concept of interleaving. I hinted a moment ago that we might be able to apply it beyond maths or math-style problems. Well, how far can we stretch it? What can we apply it to? Well, other than math-style problems, some of the classic interleaving studies look at learning things as diverse as learning to recognise work by different artists, comparing the results from blocked practice, where people learned to recognise one artist's work by looking at lots and lots of examples of that same artist's work before another set of examples of a second artist, and so on, versus interleaved practice, where examples of different artists were shown all jumbled up. Really strong effect size in that study too. Another study looked at interleaving physical activity, so practice on physical skills, where a very famous study looked at the accuracy with which people can throw a ball into a bucket at 10 feet. So the test was throwing a ball into a bucket at 10 feet. How accurately can you do that? And the interesting thing here was the people that had been doing the interleaved practice never got to practice throwing it at 10 feet. They got to practice at 8 feet and 12 feet and continually alternated their practice, throwing a ball into a bucket at 8 feet, throwing a ball into a bucket at 12 feet. Whereas the guys doing the blocked practice only threw into a bucket at 10 feet over and over and over again. And fascinatingly, the interleaved group, who'd never had any practice at all throwing a ball into a bucket at 10 feet, they'd only been alternating 8 feet and 12 feet, were actually much more accurate when they were tested on their ability to throw a ball into a bucket at 10 feet than the group who just had nothing but practice at 10 feet. Fascinating example of how, interleaving leads to kind of this more flexible and kind of powerful learning, even in sort of the domain of physical skills. So maths problems, recognising work by different artists, even practising physical skills. Anything else we could apply interleaving to? Well, I normally suggest that interleaving could be pretty handy for language grammar drills. These have sort of similar characteristics of maths problems in some ways, in that you have to recall specific knowledge for specific circumstances. So in languages, it might be verb endings rather than formulas. So languages might be another one. Just one final one, I might add, if you're a musician, I would strongly suggest practicing your scales interleaved rather than blocking your practice. I don't think there's a study done on it, at least not to my knowledge. Please do write in, william@examstudyexpert.com if you know differently. But I would bet good money that there's a powerful benefit for interleaved practice over blocked practice for something like scales, a bit like that kind of balls into bucket study for kind of practicing physical skills. Just before I leave you, I want to give you a final word of warning on actually using interleaving if you're going to start to put it into practice in your own studies. So it will feel more challenging. That is the whole point of the exercise. It is supposed to make your learning feel a bit more challenging so that by contrast, the test feels easy. Or at least relatively easy compared to if you'd done blocked practice. So the best analogy I've got to kind of sell you on this is, I don't know, you may have come across this idea that elite athletes, sometimes train at high altitude if they're trying to build their heart and lungs, their cardiovascular system, so they can run faster in the Olympics or what have you. The reason they train at high altitude is because the air is thin, there isn't so much oxygen up there, and their heart and lungs have to work comparatively harder. It makes training much more challenging, so that when they come back and race at sea level, it feels comparatively easy for their body. You can think of interleaving as a bit like high-altitude training for the mind. You are making your training feel more challenging so that when it comes to test day, it feels comparatively easy compared to if you hadn't done interleaved practice. We mentioned the Goldilocks effect way back in episode 66 of this series in the context of spaced learning. And also in the previous episode in the series, episode 6, on mnemonics and memory cues. And when I was talking about the Goldilocks effect, the whole idea was that you want to be making your learning feel a bit challenging, but not impossible. This kind of sweet spot between making it not completely easy to do your when you're doing your learning, your practice, but not impossible either. Well, it's exactly the same with interleaving. If you just learned a new problem and are finding it very challenging, I wouldn't say that's the time to start introducing interleaved practice. So do the blocked practice to start with on this very challenging new problem type until you start to just feel a little bit comfortable with solving these problems. Then for best results in shortest time, I would encourage you to push yourself on from blocking as soon as you can get away with it. Don't wait until you're 100% comfortable and happy with your blocked practice. Move on to interleaved practice sooner than it feels really comfortable. It will feel a bit uncomfortable. It will feel a bit challenging when you start interleaving. Again, that is the whole point. You are doing superb practice, and it will make the test feel much easier by comparison. If you choose to introduce interleaving on homework sheets, homework assignments that are laid out with blocking, which I recommend if you can, then I'll be honest with you, that homework sheet may take a little longer than if you'd been blocking. But the payoff down the line will be massive. You'll have learned to master that technique to a far deeper and longer lasting level than your classmates, and will therefore save yourself a ton of time over the long run when you need to study up for subsequent tests and exams. Not to mention that your test and exam scores will be much richer, much stronger as a result. Above all, remember, studying effectively isn't about making your learning feel warm and fuzzy and cozy and easy. As any elite athlete knows, your training should challenge you, and it's out of that challenge that you grow stronger as an athlete. It's out of that challenge that you grow stronger as a scholar and get the biggest results in shortest time. Studying smarter, so you don't have to study longer, in other words, ramping up the effectiveness of the time you do spend studying so that you can get the same results or better whilst reducing the time you spend studying. That's the name of the game, getting bigger results in less time. Bigger results in less time. That, my friend, is what's possible with effective study techniques. So, join me again in a couple of weeks' time for the final instalment of this course on how to study effectively, when we'll be putting it all together, summarising how to study smarter, not harder, using all of the strategies we talked about over the past 7 episodes. Which ones work well together? How can you combine different techniques to put together a complete study system that's going to get you the results you need in your exams? But finally, I just wanted to share news. I'm very excited to share this with you, that you can get a richly illustrated companion guide to accompany this entire series on how to study effectively. It's called Outsmart Your Studies, and it's available as an ebook or a printed copy. You can find details at examstudyexpert.com/study book. So if you have enjoyed this series on how to study effectively here on the podcast, and you've got exams to prepare for that involve learning quite a lot of knowledge, then you're going to love this book because it captures all information from all 8 parts of the podcast series in a really handy reference guide that can sit by your desk, ready for you to leaf through to rapidly, perfect different elements of your study strategy. It's not only about convenience, offering what I know is going to be a more convenient alternative to kind of listening through entire podcast episodes if you're just trying to work on specific aspects of your studies. It also goes to places that the podcast cannot, because in book form, I can start to offer you illustrations. So I've packed Outsmart Your Studies full of full-colour illustrations to explain and really make clear lots of the concepts we've covered in this course. You're going to see many of my trademark graphics that make important learning principles and many of the techniques we talked about really, really clear and kind of bring them to life in ways that are just often quite challenging to explain in audio form, much as I love podcasting. But as well as that, you'll also see plenty of examples of what good study technique actually looks like in practice. So at the end of the day, most of studying actually happens on paper. So if I can show you a really clear example of what good strategy looks like when you're studying, for example, what a good flashcard looks like, what good Q&A notes look like, it's going to make you much easier. It's going to make it much easier for you to actually go away and put that into practice, rather than just sort of kind of me trying to explain it to you in audio form. So I'm super excited to share this book with you. I think you're going to love it. You can visit examstudyexpert.com/study book to order your copy today. I'll pop that link in the show notes as well. examstudyexpert.com/study book. So I look forward to seeing you again in a couple of weeks' time for the final instalments of this series. In the meantime, please do check out Outsmart Your Studies. Grab yourself a copy. And for now, thanks for listening. It's been a real pleasure to have your company today, as always. Please study smart, have fun, and I wish you every success. Thanks for listening.